Hello, everyone. My name is Cody Jeffery, and I am partnered with Kelly Glenn for this assignment. Our topic is Moyamoya and the search for a suitable research model. So, we decided to look in a little bit more detail at the genetic implications of Moyamoya syndrome and attempted to identify an ideal model for future research opportunities when more advancements are made. For those unfamiliar, moyamoya is a progressive cardiovascular disease that is caused by blocked arteries in the basal ganglia that is located at the base of the brain that causes intracranial artery stenosis, brain hemorrhaging, and strokes. Moyamoya means puff of smoke in Japanese due to the appearance of brain vessels on an MRI for those afflicted, and is most prevalent in those of Eastern Asian descent, although in general this condition affects approximately 1 in every 1 million people worldwide. Our first step was to identify any known genetic markers that lead to Moyamoya disease, and in our research, we found that only one gene has specifically been linked at this time. RNF213 is the ring finger protein 213 gene and is known as E3 ubiquitin protein ligase RNF213. RNF213 is involved in angiogenesis and non-canonical WNT signaling pathway in vascular development in which it acts by mediating ubiquitination and degradation of FLNA and NFATC2, which is downstream of RSPO3, leading to inhibit the non-canonical WNT signaling pathway and promoting vessel regression. Once we knew what we were looking for, we then proceeded to find this protein in other species, and were able to locate RNF213 in 3 species that had close similarity to the markers found in the Homo sapien genome. These species are the house mouse, the domesticated dog, and the zebrafish. We then compared the genome sequence of this gene in each species against the sequence of Homo sapien to discover that the house mouse showed the most consistency in genome sequence. We used GTEX to localize the expression of RNF213 in each species. So the amino acid sequences from each species containing the localized RNF213 protein were gathered for comparison using NCBI databases, BLASTP, and Cobalt. From the sequences were aligned for comparison. BLASTP results with comparison to RNF213 protein in Homo sapiens yields low e-value but contains high percent identity. We can see a high rate of sequence similarity in the alignment of these 3 species in comparison to Homo sapiens. Using these comparisons, we can begin to gain insight into the possible development of Moyamoya disease in other species. We were able to determine that the RNF213 gene in Mus mucilis, the house mouse, has a higher degree of similarity to the Homo sapiens. We then compared the predicted functional partners of RNF213 by mapping the connections of RNF213 and the functional protein partners to both the mouse and the modern-day human using string.db.org. The interesting fact when looking at the functional connections is that in both species, they have multiple connections to proteins that are involved in the creation and movement of interferon, which is the natural substance in the immune system that fights cancer diseases and more recently has been looked at as being able to take a protective role in the patients who suffer from cerebrovascular events such as ischemic stroke or subarachnoid hemorrhage. We found that in humans, RNF213 is functionally partnered with PARP14, RTP4, HXX58, MX2, UBA7, DTX3L, USP18, ISG15, RSAD2, and a disconnection to SLC26A11. And in the mouse, the functional partners were RTP4, PARP14, RSAD2, UBA7, OASL2, USP18, DHX58, DDX30, IFIT3, and IRF7. In conclusion, we found that interferon proteins are largely connected to the ring finger protein 13, which at this time is the only known genetic link to the Moyamoya disease. We also were able to conclude that although in the beginning we had 3 strong candidates for this research model, the mouse is just slightly better, which is followed by the domestic dog as a close second option. I hope you all enjoyed our project and presentation. Thank you. Have a wonderful day.